Hi, Gerry.
Will, how are you?
Good. Welcome. We're going to try this. We're going to try this again. I have been praying to the data center gods, the tech gods,
Yeah.
that we don't get disrupted this time. For those of you joining us, we had a little tech difficulty in our first round of this conversation, but hopefully that's behind us. Looking forward to this conversation. So. Gerry, or just for those of you who don't know, Gerry Granovsky is a friend, a colleague, a senior expert in technology, media, and the telecom industries. And you've been covering all of those sectors for a very long time, in particular from a credit risk perspective. And data centers, I know, were kind of a focus, if not a special interest of yours, and that is the topic du jour. We're going to cover data centers. I think the who, what, where, when, why, the evolution, the history of data centers, I think from a perspective that hasn't been covered in the past. I know data centers, we can say, are having a bit of a moment now, pretty spurred on by artificial intelligence, of course, and they're growing like they never have presently, and the future certainly looks bright. I think we're going to cover, again, early days of data centers, how they're financed, how they're built, what the considerations are, and so on. And just for consumer credit, for the consumer credit brand of this podcast, the intersection with data centers and consumer credit is enormous, right? And at the same time, it's also something that you don't really think about that much. Virtually everything runs through or on or by a data center, including consumer credit oriented information and data and storage. Or I should say everything virtual, right? Because it's the internet, it's traffic, digital traffic. So everything from, you pull out your credit card is the most basic example, and you swipe it at the point of sale, and all that information travels, again, through many different counterparties, through many different data centers, pulling information up through your bank, about your bank account, about your credit profile, your credit score algorithm, the credit adjudication. All of this is done in the background across the country and sometimes across the globe through data centers, right? Of which, by the way, there are 2,700 at last count, 2,700 data centers throughout the country, and I think it's about 8,000 worldwide. So there are a lot of these, and again, they're being built at record speed. So that's what we're going to cover today. And Gerry, I'm sure you can elaborate further on your background. So if you don't mind, if you could just give a quick introduction before we dive right into the topic at hand.
Great. Thanks,
Welcome.
Will. Hello,
Sure.
everyone, people watching, listening to us. I am Gerry Granovsky. And as Will said, I have over 30 years of credit experience covering technology, media, and telecom. I'm currently a senior consultant at a company called Longford CRA, where we help companies structure and identify their credit risks. Prior to that, I spent 17 years at Moody's, and before that, I spent 12 years at the Bank of New York, again, all within the telecom, media, and technology sectors. And the data centers really follow my trajectory. It's really a little hidden secret of the entire technology ecosystem, because it is something that is so integral to how technology works and how our everyday interaction with any technology you have in your house, whether it's your iPhone, whether it's your phone, whether it's your computer. At the end of the day, when that signal goes over the internet and it goes somewhere, invariably that signal hits a data center somewhere. It's just you don't think about it because you never see it, or actually, chances are you do see a data center, you just don't know it's a data center.
Right.
Because essentially it's a warehouse of computers and networking gear and telecom connections and utilities, but you don't know. It just looks like a regular old warehouse with trucks outside of it. But because the data center is a warehouse, it's just a massive refrigerator box that needs to cool down all of that equipment.
So you and I both have had
Yeah.
I don't know, what do we call it? The privilege. It is a privilege. I'll call it a privilege of touring a data center in our prior professional lives. Maybe I would think that might be instructive, just to like give people a sense of what it's like to go on one of these kind of
Yeah.
financial tours of a data center, give a sense of what it's, what it looks like on the
Yeah.
inside and the outside for that matter.
Yeah, I think there are two schools of thought because when I would go on data center tours, half the people would hate it because all really it is you walk into a building and you have to pass through a lot of security actually to get inside of a data center. But then you walk and there are rows and columns of racks of computing equipment and wires and heavy duty air conditioning that cools it. And people just basically, okay, you see one data center, you've seen them all, and technically you are correct. But the nerd in me likes that because I want to see what the equipment is. Because as part of the coverage in banking or at Moody's, you see the name, so you actually want to see what happens to that equipment actually in the field when it is installed. So you want to see what the servers are. What are the companies using? Is it Dell? Is it HP? Is it third party? Is it something custom built for that specific application? What is the networking gear? How are the wires connected? And how is that data center connected to the internet? Or is it a purpose-built data center for the specific company that you just have one on-ramp to the internet, but really it's a specific data center for that company's need? And let's just go back to the case that you presented for in consumer finance, the credit card companies.
Mm-hmm.
The credit card companies were among the first major users of data center, because when you think of that process, and a lot of it happens in the background, but it has to be ultra quick. When you walk into a store and you present your credit card, and let's go back to prehistoric times when the transaction wasn't instantaneous, where you actually had to do the card swipe and it wasn't swiping through the machine, the vendor actually swiped a carbon copy receipt slip over the card, and then they would gather that, and at the end of the day, they would send all of that information to the credit card. The credit card processor had their massive mainframes sitting offsite somewhere where they would process all of those transactions. So when you think of that, it's just like that's the classic data batch processing that needed to go and get filtered through that computer system back in the day. And
so they're pulling. So back in the day, it was a companies kind of had their own proprietary data center for their own purposes. I mean, this is more of a question than a statement.
yeah.
But back in the early days, that was the beginning. It wasn't a leased space. Let's put it that way, which a lot of them are currently leased spaces, right? Is that part of the evolution of data centers? Business model has moved from single use proprietary or single ownership proprietary to kind of co-leased warehouses.
Yeah, 100% correct.
Yeah.
When we go to the prehistoric days, the foundation of the data center industry, really, there was no such thing as a data center industry. It was
right.
when
and what's
you look
prehistoric days? What is that? Is that 1960s, 1970s? What are we talking about?
let's say 1960s, when IBM dominated computing, because the only thing you could do is you could buy a mainframe pretty much from IBM. And when you look at the size of what that mainframe computer, essentially that mainframe computer took up office, it was basically an office block of computer space, and it was expensive. So very few companies could afford that. So if you were investing in mainframe access, you couldn't really share that. So it was purpose built for you in a building that you owned or building you leased, and you had private telecommunications lines from wherever you are to that building. So as you can imagine, the cost was significant, not only from the computing standpoint and the staff that would run that mainframe, the cost of very, very expensive telecommunications lines, because we're talking about, again, prehistoric. We don't have fiber
Mm-hmm.
communications yet. It
Mm-hmm.
is still heavy duty copper lines, which were very expensive. Real estate is expensive. Computing is expensive. So you really started to see the evolution of what we now is the current computer era as the circuitry improved. You started to get faster computers. The computers got smaller, and
Mm-hmm. And more
telecommunications
powerful.
lines
Yep.
more exactly. They got smaller per that square footage, and the telecommunications links became much faster. So
So,
it's like
so
all of those things were happening in tandem.
right. So you've described very well, I think, what how we can think of one data center versus another, and I think they're pretty similar, but maybe they change. We'll get into the differences in a second because I think there are some very important differences. But just to the layperson, you've got a windowless brick and mortar warehouse that is, as you said, kind of cooled to a high degree. HVAC is
Mm-hmm.
essential. You think about the heat that your PC throws off, your laptop, when you touch it, it's warm to the touch. And think about, literally thousands and thousands, tens of thousands of those stacked upon one another throughout a warehouse. They're going to throw off a lot of heat. So that's the reason you need to have reliable and powerful kind of HVAC system. That is cooling off that equipment. So that's at least one consideration. I'm sure we're going to get into the energy needs, but what maybe you can talk a little bit about what the most important considerations are if you're a data center, builder or tenant for that matter.
Mm-hmm.
What are the things that are going to be most important to you in terms of either energy or space or power? I
Mm-hmm.
mentioned power, but or proximity to the web, to the
Right. Yeah.
fiber.
All of those factors are critically important. And as we continue walking down evolution path from, the migration from the mainframes to the mini computers, you a big constraint before then, before power was really a consideration for the data centers, was telecommunication links. And the reason a lot of those computing units were close to wherever you needed to have that computation was made is you really didn't have telecommunications lines that were fast enough. So when you
Mm-hmm.
think about when you're doing the work on your personal computer, everything is integrated, everything is there, and the processing happens, and you don't have to worry about the disk. Let's give, an example that you have your processing unit on your computer here, but the storage, the hard drive is across the street. Well, that's not really optimal. So you could use that analogy to the early stage of computing is that you had to balance the cost of putting a mainframe in a Manhattan skyscraper and pay the rent of the Manhattan skyscraper when you could get cheaper land, cheaper space, cheaper energy across the river in New Jersey. The problem is it would cost you probably the same amount to do that communication link to link your headquarters office in Manhattan to an office in Jersey, which is literally just across the river. We're not even talking about 100 miles, 1,000 miles, where we see a lot of the data centers being
Mm-hmm.
spread out. So the major revolutions, in addition to improvement in computing speed, is the improvement in fiber optic capacity. And this is where the competitive telecommunications industry, when it came in the early 90s, late 80s, early 90s, and throughout the 90s, is all of a sudden, because fiber optic capacity became so widespread and covered pretty much the entire country, that speed of light communication essentially shrunk the effective distance where you could put a data center that you didn't need to be located right next to your office. You could actually be hundreds of miles away and still have the same relative performance. So I kind of wanted to add that. It's like that, the combination of servers becoming more powerful and that telecommunications link, essentially the creation of the internet and the build out of the internet across the country is what created the modern data center industry that we know of now.
Right. So you're describing something that moved from the early days that was kind of, more provincial, regional at best,
Right.
copper based, and not very, call it compute dense. But as microprocessors entered the scene and as they became more powerful, that was coincident with the ability then to send more complicated, more compute, more information dense signals through the fiber optic cable, which also allows you, I think, to propagate that signal very inexpensively relative to copper, with many orders of magnitude more throughput, right, than copper does. All of this was kind of coming together. It sounds like around the 80s, I guess, was when it began in earnest, and so that began another wave. And I guess one of the underlying, I guess, call it assumptions, I guess, or certainly facts. And I think this is an interesting way of thinking about even the current state, is that there always was demand to meet that new supply. And so some people have described the demand for compute capacity, for data, for information as insatiable. In other words, if you build it, there will be, if the supply is there, the demand will follow. They're going to find companies will find a use for that data, which is, it's an interesting dynamic. And it's certainly proven to be true. I mean, but here we are at another juncture right now with AI, and the compute demands of AI are another order of magnitude relative to what they have been. At least that's what's in the headlines right now. And the question is this going to continue? Do we need to build out even further from what we built today?
If there's one thing I've learned in my years of covering the industry is never to bet against the utilization of the capacity, because the paradigm of if you build it, they will come has held true and will continue to hold true, because at least I cannot foresee the applications, the utilization of what people will come up with, the new applications of what will eat up the capacity, because essentially it's people are like pack rats. You run out of space in one room and all of a sudden someone builds you another room for free. You're going to fill up that room immediately and you're going to need another room. So that's what's happening. Just thinking about our personal use. The storage on our phones, the storage in our computers, we have multiples more capability of what we could store. You don't have to go through. It's like, the choice now is, well, do I need to clean out my phone, or do I just pay another $1 a month to get more or less unlimited storage until the next year where I'm going to need to more? But we certainly are not running out of ways to utilize the new capacity that's coming on board, and kind of gets back to the data centers. That's why there's, at least for the foreseeable future, there will be a growing need to store or to process. I'm not even talking about AI. This is just little things that we're doing. And AI is going to supercharge the need for that compute power and data center space that's going to be built out.
And is it true that it's not just about storage? That's a big part of it. You're right. We're collecting more and more information. It's hard. I'd be hard pressed to point to an industry that isn't tapping into or creating a database. And proprietary data is more valuable than it ever has been, and it's being used again for virtually everything. And more recently now, it's being, we moved from kind of CPU centric data collection and processing now to something that's more GPU, graphic processor unit oriented, and which is a higher order task than the CPU information, and is, you can think of it as being visual, but obviously it's that would be simplistic. But what impact do you see that having on the demand for data centers, or the types of data centers that are being built today, or that type of thing?
Yeah, absolutely. And that is what's driving the growth projections from now on. Um, the analogy I would give, well, let's stay with the evolution of the
Yeah.
data center. So when we went from mainframes to mini computers to microcomputers, the main usage of a computer was still computational based. Think of spreadsheets,
Right.
word processing, emails. It was something that you needed to do your computer to process information, and to the tasks were quantitative in nature. And as opposed to graphics, when you look at your initial computers and the old green screen, it was just letters, it was text. You had your first graphics oriented interfaces were rudimentary. You still couldn't have a realistic visual representation on a computer of what you would see on your TV.
Right.
And because the difference is that the CPU, which is the central processing unit, was built to handle math equations.
Right.
It wasn't built to handle video. So if you wanted a better video, and that's the difference between a regular computer or a gaming computer, is graphics. You needed to have an extra card, a heavy duty card that would process graphics. That's why there was a difference between, if you look at your computer at home and your gaming console, they may look the same on the outside, but the inside is completely different. You wouldn't be asking your computer to have the same video representation that your gaming console can do. You wouldn't be asking your gaming console to do the things you're asking your computer to do. And that's because the main chips that power those two consoles are essentially different. So what AI in effect is a supercharged gaming console using that type of technology. That is the computing power that you need, because it's a closer parallel to what a graphics processor does in a gaming console to the work that artificial intelligence does. In a sense, trying to
Right.
replicate what the brain does, and what your brain does. Yes, you do your math problems, but you don't do your math problems as often as you visualize things, as how you try to get around life. And
Yeah.
that's why it just requires a lot. It's different compute, but just requires a lot more power and processing to do that.
I think the way I think about it is, again, oversimplifying, but the CPU is thinking or doing math, as you say, in 2 dimensions, and then once you move to a GPU, you're talking 3 dimensions. It's easy to kind of talk about it in terms of gaming and visually oriented tasks. Okay, and that's how it was used primarily in the early days, but now increasingly you're using kind of 3-dimensional, kind of vector-based mathematical techniques to produce the type of intelligence, I'll call it, artificial intelligence, that's and the results that type of technology is able to produce, right?
No, exactly. And when you look at just the increase in the computational need and the energy demand, when you're going from, let's use your example, say with a 2-dimensional computation moving to a 3-dimensional, well, you're not just really increasing it by a factor of 1. It's more, you're increasing the need by a factor of 4 to 5 because of the algorithmic nature of the change in that computation. Kind of getting back to the data center, it means that the data center design needs to be done differently than it was historically for that more quaint, simpler CPU world to the GPU world, the cooling, where in many cases, air cooling may not be enough. You may need to start using liquid cooling. Again, I go back to your gaming machine. Many of the gaming machines are liquid cooled because it's more efficient and the machine does not overheat. So you're going to start to seeing more of that kind of design going into the data center because when you think about thousands of servers, whether they're CPUs and increasingly GPUs, they just put out massive amounts of heat. And if you don't cool that building sufficiently, essentially it'll just either melt or it will go on fire because
Right.
it's essentially what you're trying to do. It's a battle between an oven and a refrigerator, and you need to come up with much better refrigeration technology to continue to cool down that oven inside the warehouse.
And as you said, um, getting back to the kind of the evolution of data centers, we've so far we described a change in the technology around both the processing density and computing ability as microprocessors became more powerful, as well as signal propagation, moving from copper to fiber. We think often about data centers being located near population densities, cities, big cities. Those often are also places where energy costs are a little higher than they might be if you were out in Timbuktu, say. Maybe you can talk about that dimension of data centers before we go into any other dimensions that are differentiators. And again, I think are important criteria for people who are thinking about data centers, either from a financing perspective or from a build perspective or equity investment perspective and so on.
Mm-hmm. No, absolutely. So once the operators realized or understood that by having a very broad pipe going into each data center, that you could shrink that distance by virtue of the fiber optic cables, that you weren't really stuck to locating the data center close in the big cities, because it's not just the energy cost, it's also, again, the real estate cost. That the primary aspect of data center location became places where energy was abundant, it was cheap, and it was reliable. So you started to see in the early 2000s a lot more locating data centers in the western part of the US, because as long as you could build the fiber optic links to those locations, you could put up a 1,000,000 square foot data center, get the energy commitments from the local utility. You would be probably paying half the rates you're paying in the major metropolitan areas, and you're good to go.
What are you giving up when you do something like that? So you're gaining a cost efficiency in terms of the energy costs, but you're no longer close to the population centers that I guess is called a traffic node, or a busy traffic node, where the information has to now go back and forth to. I know that fiber optic is quick, speed of light and everything, but you're, as we said before, there's just insatiable demand to put more and more traffic on that conduit. So what are you giving up when you put a data center in a more far-flung place if you're gaining in more efficient energy source?
No, absolutely. So it depends on the purpose of that data center. And what we saw in let's you throw more jargon in. Let's talk about hyperscale data centers.
Okay.
And what hyperscale data centers are, purpose-built data centers by the major internet companies. It's Amazon, it's Google, it's Facebook, where you are definitely reliant on the internet, but it is not as important to have that nanosecond connection to all of the other networks. So YouTube, If you're running a YouTube or if you're running a server farm and it's YouTube videos, does it matter if that video loads for the user in half a second, 1 second, or does it really need to load in a nanosecond? I would argue that if a user clicks on a video and it takes them a half a second to load, it's not as critical as if you're a high frequency trader
Right.
where you need to execute a transaction. That needs to be in nanoseconds and even less. It needs to be as instantaneous as possible. So I'm not saying that, there's still a valid need to locate your data centers as close to all the major peering points, nodes to all of the internet. That is why the Reston, Virginia area, Silicon Valley are still
New York
critical.
City,
New York City, yeah,
right?
absolutely.
Wall
Well,
Street.
not New York City, New Jersey.
Oh, New Jersey. Okay.
New Jersey. It's, yeah, very, very few data centers are actually in New York City proper, except for maybe a handful of buildings because the cost is just too prohibitive. And
Hmm.
you are at a standpoint where that distance between New York City and Secaucus or Weehawken or any places right on the other side of the river are just, it's a split second. It doesn't really matter. But the
Mm.
cost of real estate on Manhattan proper versus putting a warehouse just outside of Lincoln Tunnel, it's just it doesn't make any sense to put one in
But
New York
there
City.
are some though, right? Because there are some if you go downtown,
Right.
there are some buildings for sure that are pretty well
Hmm.
known
Yes,
that
they are
are these
known. Yep.
windowless,
Right.
skyscrapers essentially that are exactly
Right.
as you described, except they're the skyscraper version of the warehouse, right?
They are. Those actually, the ones that you would point out, and I think everyone, there's the famous one downtown New York. That's the old AT&T switching
Yep.
building. It's
Yep.
about 60 stories tall, and people, there's always the funny stories. The one that I love is people are saying it's like, well, that is a building for AT&T employees, but because there are no managers in that building, and AT&T had a policy that you could only get a window office if you're a manager, then that's why the building doesn't have any windows. Now,
Oh, jeez.
that is an old AT&T switch building because again, now we're going to true prehistoric times. If you think about how many telephone lines are on Manhattan, and all those telephone lines need to connect somewhere, they need to be switched. So that 50-story building essentially is an old building where you had almost every single telephone line in New York connecting and then going out to the long distance. The more famous building in Manhattan is 60 Broad.
Right.
Sorry, on West Broadway, and that used to be a relatively small data center. It is not as much of a data center now. It is a telecommunications hub.
Hmm.
It is what the industry calls a telecommunications hotel, where essentially you have the internet links from almost every major internet carrier in the world connecting in that building. So, we're definitely getting into the weeds, but the way uh, connections happen is all of the major companies in New York have their internet or telecom lines going into that building. And from there, you have your relationships with all the carriers. And that's how traffic goes from your offices through that building to your data center somewhere in New Jersey
Got it.
or maybe even Long Island. So
So,
New
yeah.
York used to have more traditional data centers, but because of the cost, there's probably less than 10 now.
So proximity to the major, call it highways, information highways, matters depending on your sensitivity as a company to I'll call it the latency of the signal that your business model can tolerate. And again, in your example, I thought was the best one is that, if you're a Wall Street, flash trader, every nanosecond matters. But if you're, downloading, Dune part two, you might wait a half a second before you access that movie.
Exactly. Or
just don't
when you're
care.
trying to access your photos, when you go to Google Photos, if you scroll down to, let's say, a couple of years down the line, it's going to take you some time to get those pictures that are not instantaneous, simply for the fact that it's like, okay, you're sending a signal through your computer to the internet. Google picks it up, says, okay, I need Jerry's pictures from 5 years ago. Oh yeah, the data sits in a hard drive somewhere in Utah. So it's going to take some time, as
Right.
opposed to me putting in a buy sell order through whatever trading platform.
Right.
That should be relatively quick.
Maybe you mentioned hyperscalers, so you introduced that bit of jargon to us, and you define what that is. I mean, is there anything? Is what's going? What does the competitive landscape look like now? Hyperscalers, I believe, are the largest and most dominant players, but I don't think they're the only players in the data center business model. Is that true?
That is correct. So let's just stay on the hyperscales because we
Okay.
kind of mentioned them a little briefly. In a sense, the I use the term hyperscalers and cloud interchangeably because essentially cloud computing as a business that we know, even though the forerunners to cloud computing has been around forever, but the formal term of what the cloud is essentially is an extension of the core business that Amazon had for its retail, entertainment, and everything it was running. It was what Facebook was doing with its core social media business, Google's search business, that these companies, just by their distributed nature and global reach, they had so much compute capacity that for their core business. And as part of that, they started developing their own computer systems as opposed to buying off the shelf equipment from the Dells, the HPs, the IBMs. They started creating their own OEM businesses, and then they started writing software that would run their business. And they realized, hey, this is more efficient than if we were run with some of these other companies. Why don't we start reselling this as a service to other companies? And that essentially became the cloud. So what the hyperscalers are, and the reason it's called hyperscale is that the data centers before them were smaller. But as you can imagine, just let's go back to our example for Google to run its YouTube database, to run Google Photos, you need just massive amounts of compute space. You need massive amounts of storage that really didn't exist before, unless you cobbled up all the companies together. So that is the nature of the term. So that's created a whole new industry in that because of their computing needs. And that we're talking about how things didn't exist and they utilize capacity. Well, as you can imagine, all of these businesses growing by leaps and bounds, but now they're also offering services to companies that they didn't have as customers before. Their need for data center space just keeps on growing and growing. And that's why they are by far the largest tenants or owners of data center space. But then let's go back to your original question, which is essentially, what is a data center and, how did this industry evolve? And essentially it started with companies who were in the real estate business and they owned warehouses. And one of the ways that you can repurpose a warehouse is and you might already have refrigeration in it, that you move all your groceries and produce out of it and you build racks and you put computer equipment inside of it. And there's really three levels of services you could do if you're a third-party data center operator. You could do that first part, which essentially you own the building shell. And you might have relationships with the utilities, and you might provide utilities, you might provide security services to your customers. To the second level of data center operator, which are called colocation providers, which essentially they either own the building or they lease the building from the real estate tenant, and they add more services. They actually put the racks, they put in more security, they provision telecommunications links and utility links to that building, to where we get to the third level, which is a managed services provider. And they offer more services. They actually have their own people who, because if you could imagine, if you have a data center, it's you need to have people on staff who manage the network, who manage that equipment, because computers die all the time. Hard drives die all the time. Networking equipment dies all the time. You need somebody there to reboot things, or if they don't die, just if you might have a power outage or there's something wrong with it, you need to reboot the machine, just like you need to reboot your computer at home all the time.
Right.
So you need to have somebody on site. So those are really the three layers of services that the companies could provide. And with the advent of cloud computing in the last 10, 15 years, that kind of turned that industry on its end, because it's a different decision now. Instead of thinking about, well, do I own my own data center, or do I go through the real estate provider and then I put everything else, to smaller companies saying, you know what, why don't you do everything for me, and I'll provide my own software, I'll provide my own operating systems. Where the cloud providers are coming in saying, you know what, we're going to take it to the next level. And we're going to provide not the turnkey solution, not only that building and everything that comes with it, on all of the equipment, but we're also going to provide you with the operating system and the software to actually help you run your company. That you just need to know how to integrate your business with what we're doing on the cloud, along with the security, cyber protections, and everything else that comes with it.
Right. Yeah, I do want to touch on cybersecurity, but before we get to that, I think it's worth switching gears a little bit to, now we have kind of the landscape of the players in the industry. The demand for growth is very high, as we've mentioned, but there's a constraint. Well, there's probably more than one constraint, but one of the bigger constraints is energy. These data centers require a tremendous amount of energy to run the racks and the HVAC systems, the cooling systems. And in my research on this topic, it just to give us some sense of the scale that we're talking about here. For example, is just to put, first of all, hyperscale is typically defined as 40 megawatts or larger. And if you're like me, I'm like, what is a megawatt? I don't know how to conceive of what a megawatt, or let alone 40 megawatts is. And just to kind of, maybe it's worth putting that, kind of defining what these terms mean, and putting that in terms that we might be able to understand just how much energy that is. So first of all, a watt is a unit of energy. It's a capacity of electricity that can be produced at a given time. So you think of it as, in the kind of water through the pipe metaphor, it's how big is the pipe kind of thing, right?
Right.
How much water can flow through that pipe at any point in time. We think of a watt as like 100-watt light bulb. Most people can kind of imagine what that looks like when you have an idea, right? Then you think about what a computer uses, a typical. So let's think about a GPU, because data centers are full of GPUs. That is somewhere in the neighborhood of, depending on the GPU, of course, 300 watts. Each GPU uses 300 watts. And you think about a 40 megawatts, so that's 40 million watts energy capacity coming into a data center. So 40 million watts divided by 300 watts gives you about 133,000 GPUs that raw power, again, in very simplified terms, could power. Now, not all of that 40 megawatt is going to power the GPUs. It's a lot of it is going to be used to run the HVAC system, for example, and run other things that need electricity. So you have to haircut that 133,000 by something, 60%, pick a number. But that hopefully will help folks understand what we mean by, a hyperscale 40 megawatt center can power, again, somewhere in the neighborhood of 90,000 to maybe 100,000 GPUs. And you can imagine those kind of stacked up on one another in these racks that make up a data center. So hopefully that helps ground in your mind's eye, what these data centers, are capable of doing when you talk about a hyperscale project or center.
Yeah, and I think what that does is it also lays it out in comparison to the energy that is needed to power a data center compared to our daily uses.
Right.
So we're talking about one data center the size of a massive warehouse, but it is the size of a massive warehouse that could power up a small town.
And of course, powering the GPUs is only part of the power consumption. As we mentioned, the HVACs also consume a lot of electricity, require a lot of energy. So you need all of this coming in to a 40 megawatt center. And it's at the same time, everything in the country is being electrified, right? There's more and more, including cars as the biggest example, but there are any number of things are running on electricity, going onto the grid. And so the demands on the grid have never been higher. And this is adding to that demand. And in some cases is outstripping the local utilities' ability to deliver energy. So the industry is looking for solutions to these energy needs. Maybe we can just talk a little bit about what kind of an impact that's having and how companies are dealing with that constraint.
The consistency of supply of energy, of electricity to the data centers has always been a key part. And I would say until recently, it was a key part, but it wasn't a critical part. I think now it is as critical to the development and build out of future data centers. And I think it's going to be even more critical than the supply of silicon that kind of runs the data center itself. Because as you demonstrated, there's definitely is going to come a time based on what's available now, what's known, there's going to be that supply demand imbalance that you just will not be able to provision sufficient energy to drive all the expected growth of the data centers. Because essentially what's on the board to come online, at least what's already planned, we're talking about adding a reasonably sized city to the electric grid. And where's that, especially when we're in the middle of a transition, that even though renewables are taking a much greater share, as it should, of the total grid, the downside of renewables is that it doesn't provide consistent output of energy that the data center needs. Again, if we're looking at the legacy use of energy between commercial and residential, it's easy to split the day part between 9 a.m. to 5 p.m. when people are at work, school, whatever you're doing. There's a greater demand for that baseline load to power the commercial side. And then people go home, and then that demand switches to residential. So it's kind of, the two are rarely humming at the same time. as opposed to the data center. And right now, Department of Energy estimates that they account for 2 to 3% of the total energy consumption right now.
Right.
The estimates are that it's going to go up to, I think we talked about this, 8 to
8%.
10%. Right.
Yep.
And that's a huge load.
Exactly. According to a Goldman report I just saw recently, they forecast by 2030 that it's going to move the energy consumption as a percent of the U.S. Total consumption is going to move from 3% to 8%. That's a tremendous increase.
And that's absolutely new demand. It's not as if you're replacing something.
Right.
A new data center is just taking up capacity of something that is created from scratch. It is not taking that energy utilization from something else. So that's the critical part. And where's that energy source going to come from? I think the industry is definitely talking with the utilities, but I think the upshot is that there's definitely going to be delays in sunsetting some of the old fossil fuel plants, whether it's coal, whether it's oil, or whether it's natural gas. And I think talking to the oil and gas industries, I think everybody recognizes that gas-fired power plants will have a major role to play in supplying the energy. The industry is talking, looking at some of the innovations, whether it's, as I said, liquid cooling, that you don't need as much air conditioning, or whether, it's experimental small nuclear reactors that are actually powering the sectors. Those are happening more in the international markets than the U.S., but it is definitely a major source of friction that's going to need to, to be addressed, because right now there's no alternative.
Yeah, I was going to say, is it? I mean, this is not just a data center problem, right? I mean, this is all about moving away from fossil fuels is a global kind of endeavor. Time is of the essence. At the same time, we have these incremental demands on energy that are, as you've just described it, are outpacing our ability to convert to the more green. I mean, gas is greener than coal. Okay, that's a step in the right direction, but it's not going to get us to, I think, the international targets that have been established now for the incremental change to burning of fossil fuels and carbon carbon footprint, rather. Right. So
I think it's definitely a good point, because it's not just the generation capacity, but does the distribution network, does the grid, the electric grid itself, can it handle the increased load that you mentioned, the electrification of vehicles and more electricity that is consumed at home as we're moving away from the traditional furnaces and boilers, that there's going to be a greater need. So one thing to think about is distribution of that compute capacity away from the data center, more closer to where that content is actually created and needs to be computed and needs to be processed and turned into its final form.
This is edge computing?
Some people call it edge computing. I call it my iPhone, or the iPad, or it gets back to your computer. So essentially what you can do is, instead, we could do a full 360 on it, or 180. When you had the computing power and you had the faster networks, you would ship off all your heavy processing from your home to a central farm somewhere, and it comes back to you. Can you reconfigure your network? Can you reconfigure what you're trying to do and do it at home? Do it closer to the spot where you actually are. So in a sense, it would be going back to the prehistoric days where the mainframe was one floor below you.
Right.
Yeah. So we could definitely, talk about that a little bit more and, what's happening on the industry side.
Yeah, I think that's worth going into because that's kind of the future state, right? I mean, these are
Well,
the dynamics that are affecting supply and demand. And as you said, we've had, I think of it as edge computing is used is a bit of jargon that's used to talk about using compute power that is called local, either very local, like you said, your iPhone or your phone, where the computations are literally being done on your personal device or your computer. But it can also mean just doing things more, doing that same type of computation rather, closer to wherever you happen to be. And often this is talked about in the context of the Internet of Things, right? And basically
exactly.
everything interacting in some way, shape, or form, either on the internet, maybe not using all of the bandwidth or capacity that today is resident in data centers, but kind of using some of that, but also interacting with something that is resident on the device itself. So whether that is a phone, your computer, your refrigerator, or nowadays your vehicle, right, your car, these are ways of spreading, as you said, spreading the compute supply across different sources or sources other than the data center itself. And that kind of alleviates some of the pressure from the data center nodes. Is that what you have in mind?
No, absolutely. Just when we distill it and just into the components and, just again, I'm going to use my very simple examples. Chat GPT, when you're using it right now, you
Right.
type in something in the search box, then it goes into the internet, it goes to the server, processes, and you get something back within 30 seconds, hopefully faster than that. Um, and all you need to write a letter. So why do you actually have to type the question on your phone or on your computer? Why does it need to go halfway across the country into a data center and compete with 1,000 other people that are sending very similar but more or less rudimentary requests? It's not a major computation. You're not trying to solve a major riddle like a hospital would be trying to do. So as you are improving the silicon at home closer to you, whether it's on your computer or whether it's on the phone, a lot of that processing could happen locally or closer to you as opposed to being sent to the central data center somewhere.
Mm-hmm.
And I think the more, and especially with a car, again, auto driving technology, everything was resident in the car, but you're still sending a lot of signals back to a central collection point for processing and everything else. If you can improve that technology at the edge, and that's what we're talking about, whether it's the car, refrigerator, anything else, that will certainly alleviate the need to have that massive computing graphics capacity in a data center, central data center, and that was going to solve things. But what it also means is that you will need to improve the quality and ubiquity of your telecommunications network. So again, when we talk about these sectors, there's really you can't disaggregate the importance of computing, the silicon part, the networking part, and the telecommunications part. That is just so important because you need to have that ultra fast connection, whether it's wireless or whether it's your home. You need to have the fast, whether it's cable, whether it's fiber. But the old days of 2 megabit a second internet, that's a thing of the past. You
I
need to
think
have super, super fast connectivity no matter where you are.
I think we'll have to have another podcast on wireless alone,
Yeah,
right?
yeah, absolutely.
Because that's a whole nother topic that's very related, but has it's a different rabbit hole that we can go down for sure. Um, what about financing, how, they're fairly capital intensive, as we've described. You're building a building, and there is, the technology in many cases is being supplied by the tenant or the lessee, but you still have to, secure the land. You have to get the access to the energy. In some cases nowadays, you're going to have to actually build the energy source, right? So there's that part of it as well. Building a utility scale power plant is not cheap. How are these data centers being financed today? Or maybe we should even go back and say, how are they being financed before, a couple of decades ago, to how are they being financed today, and how has that evolved?
Yeah, essentially the industry is an outgrowth of the traditional real estate industry. It really wasn't started by telecommunications or computer companies. Essentially, the information services companies went to their regular real estate partners, the same people they were dealing with when they were building office towers, because that's where the data centers used to be. And they said, hey, can you please build me a warehouse because I need to put my computer equipment in it? And they were financed how traditional real estate was financed, and you use the same metrics. And interestingly, as the information services companies who were data center experts, when they went into the business, they first obtained financing in the traditional ways as a corporate company. And the metrics we looked at were the same corporate metrics we look at for a commercial client as opposed to a real estate client, because there are differences in what you look at. You look at cap rates, you look at occupancy rates. You don't look at that when you're analyzing IBM or Microsoft. So the specialty data center providers realize that by following a real estate model, it opens up a much broader window of opportunity for you to tap the most advantageous financing market, especially if you incorporate yourself as a REIT, because then you could obtain traditional corporate financing. You could go into the securitization market, the commercial, the mortgage-backed security market, because especially now that we have a strong record, really 30 years plus, of tenants leasing space in these special purpose warehouses. And what we have found is there haven't been a lot of defaults. We go back to location, that if you happen to have a location that is valued by the customers, whether it's for energy utility reasons, or whether it's for connectivity reasons, or whether it's for that specific client that needs to have it, that space, it goes back to the adage, location still rules. That even if you need to replace the equipment inside that data center, the fact of where the data center sits, it is still very valuable for the renewal rates. So it's from a fixed income standpoint, it's a great business.
I know some of the things some of the things that the looking at it from a finance perspective, that people were thinking about deeply, in terms of risks, were this releasing risk. And as you said, that hasn't materialized, in any, it hasn't materialized, in any, call it a fundamental way, across the industry. There are concerns around, technological innovations. Anytime you have something, where there could be a breakthrough in technology, but that, again, as we've discussed, at least so far, the technological innovations have been met with demand, for the given supply, or the demand is in excess of the given supply. So the demand for the centers remains, right? I think another thing that I remember being discussed is like, which is very topical nowadays, is also resiliency of the brick and mortar itself. In other words, exposure to natural disasters. So to the extent that any of these data centers are near population centers that are prone to, call it floods or hurricanes or fires, or any number of natural disasters that are hitting the headlines nowadays, seemingly with more frequency and severity, and the insurability, right? That's a cost that gets passed through to the lessees typically. These are all factors that are headwinds or potential headwinds or risks to the financing business model today, despite, some of the tailwinds that we talked about, which are also very strong.
I would actually turn those headwinds into tailwinds. One aspect of the growth, the history of the growth of the distributed third party co-location, however we want to call them, data centers, actually was 9/11. When the Twin Towers came down, a side effect of the disaster was when the buildings collapsed, they severed a major communications link between the New York Stock Exchange and the Verizon hub, which was right across the street. And that was, if I recall, the main reason why the New York Stock Exchange didn't open for a couple of days, because there wasn't enough redundancy in the communication from that building to the traders across the world. And after that, the SEC set up a commission, and effectively they mandated that a lot of the critical businesses have redundant facilities, information technology facilities, outside of what they defined was a blast zone. And that spurred a lot of data center build outs, at least for New York City based companies in New Jersey, that you were still close enough, but you were far enough. So I think the blast zone may have been defined as 100 to 150 miles.
Got it. So you're saying that these risks of natural disaster or terrorism, since 9/11 have spurred resiliency and redundancy that should mitigate any one node being compromised, again, through any number of means. So when you say turning a headwind into a tailwind, that's because the industry responded in a way that has hardened the network effect, if you will, of data centers in general. But that's true of the network taken in aggregate. But if you're just, and maybe this is my naivety about how these things are being financed, but if you're just financing a specific site, are you still not exposed to that specific site's vulnerability? Or are you saying that because of redundancy and resiliency, that it's not likely that that data center's ability to communicate with the network would be compromised, or wouldn't be compromised for very long?
Right. It's a combination of those, because as part of the resiliency, you cannot have one site that hosts everything. And we faced a live test during Hurricane Sandy, where we had resiliency plans. And, when I'm saying we, I was part of a team, so I'm not going to give away too many corporate secrets, but a lot of companies had that they had to build in business continuity plans for their businesses. And since we are in the information technology business, that every single company that has critical systems, they needed to be remote, but you also needed to have backup. And during Hurricane Sandy, essentially, when Manhattan was shut down for essentially a week, you didn't see the disaster stories that I guarantee you we would have seen if those plans were not put in place after 9/11.
It was
So,
still
but
pretty disruptive, though.
it was disruptive, but it wasn't fatal. It
Right.
would have been fatal for many companies to be completely shut out of your offices, not have access to anything for 7 to 10 days.
Right.
So the way I'm turning this into a tailwind is that essentially you need to have that redundancy of facilities. It's not just communication links, it's the systems, it's everything else, and that spurs demand. So there are data centers around the country that are just essentially do nothing but serve as backups. That if your main data center goes down, you instantly turn on your backup and you're good to go within 5 seconds, uninterrupted.
Okay. Got it. So we have kind of a REIT structure. We have the securitization. We have commercial real estate. We have, I would say, project finance, particularly for those that are being built out, and you have some construction risk. Probably follow a project finance kind of financing model. Slightly different risks involved there. So those are the main ways that these businesses are these data centers are being financed today. Is that fair?
That is definitely fair. Yep.
Okay.
And that's why it's such an attractive business for fixed income.
Right.
Again, because just stability of that demand, the even at the end of the day, the repurposability of that building, which is built to much stricter standards than a warehouse. But at the end of the day, you could always convert that building into a warehouse.
Right. I mean,
in the unlikely event that all your tenants leave.
But are you going to get the same kind of, I mean, that's the question that they refer to in the industry as the go dark risk, right? So, what are the alternative uses for a windowless brick building, as you say, a warehouse, a hyper air conditioned warehouse? I mean, yet you could use it as a warehouse, but are you going to get the same kind of rent rolls that you would have gotten that you're getting now as a data center?
Well, you definitely won't, but we're talking about at which iteration of financing are we, and at what stage are we, right?
Right. So that's more likely to happen further out after your first wave of prime lessees, contracts or leases have turned over. Yeah. And these are typically 10, 15 years with
10, 15,
rights to renew for another 5 or 10 years kind of arrangements.
Exactly.
Very long term.
And it's not even after maybe it's after the second round.
Right. Okay. Why don't we turn to the future a little bit and just, kind of think about, I'd love to hear your thoughts on what you're thinking about as to what's in store for data centers from any number of these angles that we've talked about, just kind of to wrap things up a little bit with a look into the crystal ball. What do you think, is the role of data centers, the risks that you think might manifest, if any? I mean, we've talked about several of them. I don't know what kind of, likelihood you may place on some of these risks, be it energy constraints we talked about, or innovation or technological risks, if there's something big on the horizon that we haven't talked about yet. And are two that come immediately to mind. It could the edge computing could really take off and maybe be a bigger factor than we had assumed. I'd love to get your thoughts on that. And
yeah, I would say, we touched upon it. To me, the biggest risk is the energy supply and the consistency of that energy supply, because it is one of the few major sectors of the economy that needs power consistently on a 24/7 basis, uninterrupted. And I think there will be a concern down the road of, okay, where do we start prioritizing? What do we prioritize to meet the growth? I think edge computing, I don't see it as a risk. I see it as an opportunity as well, because again, it's going to drive more applications. It's going to drive more uses that we haven't thought of and someone hasn't thought of, but you give somebody the tools and they will come up with some interesting ways to use those tools. So I think for the data center business itself, just because we are still at a relative undercapacity
Mm-hmm.
for what is coming, I don't see any near-term risks, maybe even out in the longer-term horizon.
If you build it, they will come.
They will come. Yeah,
And
that's
I mean, it has certainly played out. I don't trust my personal experience and intuition on this to that much, but it is, in our faces every day over the years. Like, can you imagine doing the type of work on the computer that you owned 10 years ago, right? And or the iPhone. The iPhones came out about 10 years ago. I mean, that thing would be a paperweight today. In terms of its compute capacity. It just wouldn't meet the standards. And the more things that those devices are capable of doing, the more uses we find for it. And I think you can kind of, again, my intuition tells me you can apply the same logic to data centers, right?
well, do you just what we're doing right now? It would have been impossible to do this podcast with video, the sound quality, just with me plugging a headphone in to the USB port, and that's it. You
Right.
obviously have much more sophisticated equipment. I don't. I just have my old headphones and a plug. And I just plugged it in. That's part of it. The one caveat, actually, I would like to, we're talking mostly to a fixed income audience. I have never been as optimistic on the data center business from the equity side, just because in some of the things that we've talked about, there is a need to refresh the equipment inside the data centers. Maybe not so much the energy supplies and the transformers, but the way data centers work is you get the main power in. You have these massive banks of batteries, at least right now, that provide the backup power. The data centers are actually run on DC power, so you need to convert the AC current to DC current. So you need to continue to update that monitoring equipment, the network monitoring. You need to, and most importantly, you need to replace the equipment inside the data center. The useful life of a server or storage unit, we're talking about 3 to 5 years max, because it's not
Isn't that the lessee though that is responsible?
Well, it
for
doesn't.
the cost
It really
of that?
depends. Well, it really because what we've seen is there has been the convergence of the operators, so you don't have as many pure play REITs that were just building the shell and the co-location providers. We've seen, Digital Realty, the company we know very well. Traditionally, they would just provide the shell and then would let the customers provide everything else. Over time, they have been buying more co-location providers. They have been buying more managed services providers. So as you collapse your business model to provide the full suite, you are going to be much more exposed to that technology risk. From, to deliver the returns you need to deliver to equity, as opposed to fixed income. You just care that your tenants are there and they're paying on time.
Okay. Anything else, Gerry, that we didn't cover yet that you want to convey to the audience on data centers?
I'll probably think of something tomorrow. I'll send you a note, but This has been great.
It has been. It's been super interesting. I learned a lot, and thank you very much for taking the time to discuss data centers. I hope to have you back on for any number of other topics that you're an expert on, but this has been really informative. Really appreciate it, Gerry. Thank you.
No, great. Thank you. I enjoyed this. Thanks.
We'll call it a podcast. Thank you.
All right.
Take care.